This is the engineering admissions assessment for November 2020. So this is the rapid fire multiple choice question stuff. I did say I wasn't going to do any more of these, but some people have been asking, so I thought I might as well do a few more. There are 40 of these questions. I'm going to split them into two videos. So in this one, I'm going to do part A. So that's the maths and physics, 20 questions. And then I'll do a separate video for advanced maths and advanced physics. So let's see how we get on with these. Question 1, we've got a soldering iron, copper tip of mass 2 grams. So see they've given us specific heat capacity in kilograms. So quickly flip that over. Tip is heated with 30 watts of thermal power in 50 seconds, so 1500 joules. The temperature is increased by 200 degrees C. How much energy is transferred from the tip to the surroundings in this time? So how much energy have we lost to the surroundings? So what do we need to go up by 200 degrees C for a pretty small soldering iron tip as that? So we need 400 times 200 times 0.002. That's what we need. Let's tidy up some zeros here. Grab another one off of there. So we've got 4 times 40. So we only need 160 joules and we've put in 1500. So we've lost 1340. So that's C. Question 2, admission charge to a cinema is different for adults and children. 2 adults plus 3 children is £20. 4 adults plus 4 children is £34. And we want to get 6 adults plus 2 children. Okay, so actually we could halve this one rather than slightly unusual what we usually do on these simultaneous equations. Normally we're multiplying them up, but that gives us that a child is £3. So an adult will be 5.5. So we want 33 plus 6 is D. Okay. Question 3. Uranium-238 decays by alpha and beta emissions down to lead-206. How many beta particles are emitted in the decay of one uranium-238 down to lead-206? Okay, so we've got a drop by... how many is that? 32 in mass number. So we're going to need 8 alphas, which is going to take 16 off the proton number. We only want to take off 10. We're going to need 6 betas. Get us back up there again. Question 4. Fair spinner has 8 equal sections. Each section has one number written on it. Okay. It's spun twice. You add the 2 numbers. What's the probability the sum is 5? So we need a 3 and a 2. So 3 is half of them, 2 is an eighth of them, and we could go 2 then 3 or 3 then 2. So we'll have to double it, and we're just left with an eighth. A. Okay. Question 5. DC electricity transmission. Yada, yada, yada. On a particular day, we supply that and receive this. What is the percentage efficiency? How much energy is wasted every minute? Right, so we're supplying a wattage of 4 times 10 to the 5 times 2 times 10 to the 3. So we're supplying 8 times 10 to the 8 watts. And we're receiving 1.6 times 10 to the 5 times 4 times 10 to the 3, which is 64. So 6.4 times 10 to the 8 watts. So we're losing 16 there, or 1.6 out of 8. So we're losing a fifth of it. So it's none of those. And we got 1.6 times 10 to the 8. We're losing that number of joules every second. Multiply that by 60. So we're going to end up getting 96, or, oh, they've taken an extra 10 on there, 9.6 times 10 to the 9. Yeah, they got some quite nice numbers there, made it easier. Consider the 4 lines with these equations, which 2 are perpendicular. So what gradients have we got? We've got minus a third there, we've got a third here, we've got 3 there, so 1 and 3 already. And then this one's got, well, it's minus 2/3, so 1 and 3, B. Okay, and question 7. 2 fixed horizontal metal rails side by side 12 centimeters apart, so it's in the picture. Rails are connected, DC in the picture. Movable metal rod 20 centimeters placed on the rails, and we've got a 90-degree angle. Right, so that's all in the picture. Whole arrangement is played in a uniform magnetic field of magnitude half a Tesla directed perpendicularly into the page. Right, so we've got that. Movable rod has a weight of 0.4 newtons. Switch is closed. There's a current of 2.4 amps and the rod moves. What's the initial magnitude of the acceleration of the rod and in what direction? So, well, let's get the direction first. So right hand slap rule, fingers into the screen. And then we've got the current to be going down the wire, so it's going to push to the right. So we know it's moving to the right. And then we've got our mass times our acceleration is going to be our BIL. So a half times 2.4 times 0.12. And the mass is equal to 0.4 over 10. Right, okay, so let's start converting some of these things around then. So I could make that into a 1.2. I could make that into a 1.2. And then I can divide by 0.4. So I'm going to have a 3 times 1.2 is 3.6 off to the right. Do we have that on there? 3.6 to the right. There we go. F. Right, 8. Find the sum of these solutions of this. I've got the same bracket, so 2y squared minus y minus 36 is 0. Looks like it's going to factorise. So 2y, y, I want the 9 and 4. 9 have to go there, 4 there. That'd be the plus, that'd be the minus. So I've got y is 9 over 2, or y is minus 4. And y was what? X over 4 plus 3. So that would be minus 7 times 4, x is minus 28. Here I've got 4.5 is equal to x over 4 plus 3. So x is going to be 6. And I want the sum of these, minus 22. F. Question 9. Two trolleys are moving towards each other along a straight horizontal track. One has got mass 8. Travelling to the right at 4 meters per second. The other's got mass 2, travelling to the left at 1 meters per second. Collide and stick together. How much kinetic energy is transformed or transferred to other forms of energy in the collision? So conservation of momentum, we're going to have 32, well, minus 2, because it's moving the other way, is going to be 10 times the new velocity. So it ends up all moving at v is 3. So we're going to have 45 joules of kinetic energy after the collision. Beforehand, we've got 4 times 16 plus 1 times 1. So that is 65. So we've lost 20. C. Question 10. When that expression is written in complete the square form, what is the value of r at the end? Right, so 4x squared plus 12x plus 9 minus x squared, that would become a plus 6x minus 9. Get rid of that, get rid of that. 3x squared plus 18x. So 3 lots of x squared plus 6x. Okay, so 3x plus 3 squared. So I'll have to take off 27. A. Right, so that's half of them done, but they get a bit more involved as we go on. So we've got a car of mass 800 kilograms, travels in a straight line along a horizontal road. I'll write that down there. I'm sure I'm going to have to scroll down. It accelerates non-uniformly for rest for 5 seconds, then moves at constant speed. Okay. What's the average resultant force acting on the car over the time for which it's accelerating? Right, so we need to know where it got to in terms of its speed after this. So what are we doing? This straight line here, we're doing 30 meters in 5 seconds. So we're going at 6 meters per second at the end of all of it. So our change in the velocity is the accumulation and acceleration. So 6 is going to be acceleration times delta t, which is 5. So we've got acceleration is 6 over 5. And we want the average resultant force. So we want to multiply that by the mass. So we're adding on a fifth. So we're adding on 160. So we want 960, which is D. Right. Number of pairs of winter boots sold on a day is inversely proportional to the cube of the outside temperature. So sold is inversely proportional to the cube of the temperature. When the temperature outside is 8, we've got 250. So 250 is K over 8 cubed. The next day, when the outside temperature is X, so we've got an X cubed on the bottom, still got our K. Number of pairs of boots sold is 700% more. So 8 times 250 is equal to that. What is the value of X? So X cubed is going to be K, which is 250 times 8 cubed. And then we want to divide by 8 times 250. So we want the cube root of 64, which is 4. Right. Question 13. P and Q are two fixed points on the surface of the ocean 6 meters apart. P, Q, 6 meters. Ocean wave travels in a direction P to Q. Wave has a frequency of half a hertz, so we've got a wave every 2 seconds. Travels at constant speed. A peak passes Q at time t is 0. Okay. And then the next wave peak traveling towards Q passes P at t is 0.8 seconds. So we've got another 1.2 seconds to get to Q. What's the speed of the wave? So it's doing 6 meters in 1.2 seconds. So it's doing 5 meters per second. So that is that one. In a sale, all prices are reduced by 25%. Customer calculates the pre-sale price of a bicycle incorrectly by increasing the marked sale price by 25%. Customer's calculated pre-sale price is incorrect by £15. What is the correct pre-sale price? Right, so what's happened on this then? So we want to get this. Let's call that X. So they've taken a pre-sale price and they've reduced it by 25%. So we've got 3/4. Some customer who can't do maths then increases it by 25%. So they're multiplying by 5 over 4. So they've got a value which is 15 over 16 times X. And that's out by £15. So a 16th of X is going to be equal to 15. And X is going to be 15 times 16. So 225 plus 15, 240. E. All right. Okay. Oh, gone a bit too far there. Parachutist of mass 80 kilograms drops from a plane traveling at that speed at that height. They hit the ground at that speed. How much work is done by the parachutist against drag forces? So we're doing a conservation of energy. So we started off with a half m times v squared. Okay, plus an mgh, so 80 times 10 times that. Okay, so what is this all in all? 40 times 40 times 40. So I've got 64 with 3 zeros. And then here I've got an 8 times a 2 gives me a 16. And then 1, 2, 3, 4, 5 zeros. 2, 3, 4, 5. Oh, that's quite good. So that comes out at 1664,000. What do I get at the end? I've just got a half mv squared. So I've got 40 times 25, which is 1,000. So I've lost a lot. So this one, D. Difference between the two. Question 16, all good geometry like this. In the diagram, QS is perpendicular to PR. Yep, fair enough. They've marked that. PS is X. Yep, they've marked all those, X, Y, Z. They've marked the angle, so it's all there. PSR is a straight line. Yeah, okay. Which of the following is an expression for the length of Z? Right, so what we got then? Z sine 61 is equal to H. And the H is the square root of y squared minus x squared. So I want to do y squared minus x squared divided by sine of 61. Y squared minus x squared divided by sine of 61. F. Okay. 17. Light spring, unstretched length 0.1 meters, spring constant of that. It's suspended, so it's vertical. Okay, we've got a mass stuck on the end. And we pull it down that length, then we release it. What's the speed when it returns to the unstretched length? Okay, right, so that's another conservation of energy. So we got a half kx squared. That's what we're starting with. So that's a half times 20 times extension is 0.2. So we've got that. And that is going to be equal to, we've now got an mgh, so that's our m, times our g, times our h, plus a half times m, times v squared. So we need all of this in here. So let's start doubling a few things up then. So let's multiply everything by 2, gets rid of that, makes that a 0.1, which cancels with that. I've then got this 0.05 here, so multiply by 20 on that. So I'm going to have 20 squared times 0.2 squared, and then minus 4 is v squared. So this is a fifth of 20 is 4, and then I'm going to have to square it all. So I've got 16 minus 4 is v squared. So v is root 12, which is g. Okay, 3 to go. Vertices of a square are at 1, 1 and 3, 5. What is the difference between the perimeters of the largest and smallest possible squares that can be drawn with these points? Well, if we're going to get the largest square, these will be adjacent corners, and the smallest square, they're going to be diagonal. So if they were adjacent corners, what are we going to have then? We're going to have adjacent corners. So the difference here, we've got a 2 and a 4. So that's 16 and 4 is 20. So we've got a root 20 for a side. So we'll have 4 root 20 would be the perimeter. That makes sense. And then diagonally, that means we're going to have a root 20 is going to be the diagonal. So we're going to have that 2x squared is going to be equal to 20. So using Pythagoras, so we're going to have that x is going to be equal to root 10. So we want to do 4 root 20 minus 4 root 10, which has got to look like one of these. So we've got a lot of root 5s kicking around here. And just wondering what way to factorise on all of these. I mean, it's not going to be any of those ones, and it's not going to be any of those, and it's not going to be that. It's got to be one of these ones in the middle. So it looks like I'm pulling another 2 out of that to make that an 8 root 5. And then minus a 4 root 10. Is that going to work? Then factorise the 4 root 5. Yeah, so 4 root 5, 2 minus root 2. Yeah, D. Okay, yeah, that was interesting. Question 19. A rocket travelling in space is burning its fuel at a constant rate. By expelling the burnt fuel through a nozzle, the engine is applying a constant force to the rocket. What is happening to the magnitude of the acceleration of the rocket? Wow, okay. Is it increasing at an increasing rate, constant rate, decreasing rate, not changing, or decreasing at an increasing rate, constant rate, decreasing rate? Right. Well, it's definitely not going to be any of these. So because, okay, we'll have to do a bit more working out on this, but if you had your rocket moving along with a constant force on it, and it had a constant mass, then you'd get a constant positive acceleration. Actually, maybe, oh yeah, okay, no, this does fit with the explanation. I'm just, yeah, getting myself a little confused there. But no, if we had a constant force with a constant mass, then we'd have a constant acceleration, so we'd get D. But now the mass is dropping, so the acceleration is going to be increasing because we've got the same force, but on a decreasing mass. So we're going to have an increasing acceleration. But the question is then, what is happening at the rate of that increase in acceleration, which is not as obvious as to what we're going to end up actually having off of all of this. So we're going to have to go back then to, because we can't use F equals ma, because that's the constant mass. So we're going to have to go back to our more detailed description of Newton's second law, say that the force is the rate of change of momentum. And then that is the d by dt of mv. We'll have to product rule that. So we're going to have an m dv dt, and we're going to have a v dm dt. Now we know here, because it said that it's burning the fuel at a constant rate. So our dm dt is a constant. So that's something that's going to be useful. And we want to know we already know the acceleration is increasing. We want to know the rate of the acceleration. So we want dA dt. That's what we're trying to think of, or d2v dt squared, same thing. So it would suggest that if we then differentiate this again, we're going to get an equation with that in it. So we're going to have df dt. We've got constant force, so that'll be 0. Then we're going to have a dm dt dv dt plus an m d2v dt squared. So that's the thing that we're after. Plus a dv dt dm dt plus a v d2m dt squared. Okay, so that is 0. This thing at the end is 0 because dm dt is a constant, so we've got 0 there. We've got 2 lots of this. We've got 2 lots of dm dt dv dt, and then we've got an m times the dA dt that we're looking at. So we want to get an idea of whether this is positive or negative for the dA dt. So dA dt is going to be minus 2 over m dm dt dv dt. Okay, right, so what do we know about all of these? Well, we know that m, that's positive. We know, so dm dt, so the rate of change of the mass of the rocket, this is negative. And then we got dv dt, so the acceleration, and we know that the acceleration is positive. So overall, we're getting that dA dt is greater than 0. So it is increasing at an increasing rate. So that is really involved compared to the previous 18 questions, but there you go, it's quite a nice one. Then what we got, last question out of these, a quadratic equation 2x squared minus px minus 4 has two solutions that differ by 6. What is the value of p? So, well, the things that make the quadratics differ is the plus or minus in the square root bit. So we need to have that the square root of b squared, so p squared, so minus 4ac, so that's going to be 32 divided by 2a. That has got to be equal to 3. So we're going to get p squared is, as in half the difference. If one of them's plus 3, the other one's minus 3, we end up getting a 6 difference. So p squared is going to be equal to 12 squared minus 32. So 144 minus 32 is then 112. So we've got the square root of 112. So, well, 16s go into 112 because, well, they do, because that's 7 16s. So we're going to have 4 root 7, which is B. Okay, so that's wrapped up those 20 questions. I think by and large, I mean, question 19 was notably difficult. The others were the sort of thing you'd expect in the first section. So got through those ones relatively quickly. I'll be back for the other 20 in the next video.